To review for the final, we're going to go through all the problems on the review. The first 9 questions are on factoring. I won't be writing down all the directions, but these are to factor completely, and I'll write prime if something is not factorable. Problem number 1 has 9x squared minus 9x minus 54. Going through my steps, do I have a common factor? Yes, 9 is a common factor. That would leave me with x squared minus x minus 6. And I'm going to take those lines away. Then check and see, can I factor this trinomial? Yes. The last sign is negative. That means I need one of each. I need an x and an x. Factors of 6 with a difference of 1. That's going to give me a 2 and a 3. And this is not an equation, so I don't set equal to 0, I don't solve, I'm done. It was just factor. And I need all of these factors to get credit. Okay, problem number 2. I have 3x squared minus x minus 24. Is there a common factor? No. I see 3 terms, trial and error, so I'll go with the 2 binomials, 1 plus and 1 minus. Well, I know I need a 3x and an x. And now I need to work with the factors of 24, and I have choices. I have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And those simply have to be put in combinations with the 3 and 1 that are already there. So there really could be some trial and some mistake and so on. I'm going to try the 3 and 8. I'm going to put the 3 down here so that it pairs up with this 3, giving me with a negative 9x. Then I'm going to put the 8 in the middle. Whoops, sorry. The 8 in the middle. That gives me 8x, and that does work out. So I didn't make errors in that one, but certainly it could have taken a few trials for me to get that. So 3x plus 8 times x minus 3. And certainly please call my attention to it if I either make an error on this or if you see an error on my solution pages, let me know. All right, number 3. I have 6x squared minus 21x minus 12. Do I have a common factor? Yes, 3. 3 goes into 6x squared, 2x squared times. 3 goes into 21x, 7x times. And 3 goes into 12, 4 times. So I'm going to keep the 3, don't lose that factor. And 1 plus and 1 minus. 2x squared, that's going to be a 2x and an x. No choices there. And let's see, a 4, I could either use 1 times 4 or 2 times 2, and I'm going to use the 4 and the 1, and that gives me an outer product of negative 8x and an inner product of 1x, which works out. So maybe I'm just on a run of good luck right now. All right, number 4. I have 25x squared minus 16. There's no common factor. This is a binomial. I have 3 kinds of binomials, the difference of squares, the sum or difference of cubes. This is the difference of squares. The difference of squares factors into sum and difference product. 1 plus, 1 minus. I need 5x plus 4 and 5x minus 4. Still not an equation, just a polynomial for me to factor. Number 5 is x squared plus 16x plus 64. Now, this one is a trinomial. Do you happen to recognize it as something special? Maybe you do. It is a perfect square trinomial. So if you saw it as a perfect square trinomial, you would take the square root of the first, x, the square root of the last, 8, sign from the middle, it is x plus 8 squared. If that was not apparent to you, it would be absolutely fine for you to write it as x plus 8 times x plus 8. Whoops. So it doesn't matter to me. Having just done completing the square, you might be a little bit better at recognizing those perfect square trinomials. Is that okay? All right. Number 6 is x cubed minus 125. All right, that is the difference of cubes. The difference of cubes has a pattern. Into the binomial goes cube root, which is x. Keep that sign, minus. Cube root, which is 5. Into the trinomial goes square, x squared. Change the sign, plus. Product of these two, 5x. Square of the last, plus 25. Square, change the sign, product, square. Number 7 is t cubed plus 8. It's another cube. It's the sum of two cubes, but that really doesn't change the way I do it. The cube root of t cubed is t. Keep the sign. The cube root of 8 is 2. Square the first one, t squared. Change the sign. Product. Multiply these for 2t. Square the last one for 4. All right, number 8. I have 21x cubed minus 64, just 6, x squared plus 15x. Is there a common factor? 3 and x. So 3x is a common factor. It goes into the first one, 7x squared times. It goes into the next one, minus 2x times, and it goes into the last one, 5 times. Now I want to see if maybe I can do a little bit more. Keep the 3x. I know I need both of these to be minus, and that doesn't look like it's going to work very well. It's not going to work any further. So I believe this is where I have to stop the problem. Okay, so this can't be done. It is not prime because you were able to do some factoring. You just couldn't do anything with that trinomial. Okay, so sorry about the mistake in those solutions. Ooh. Number 9, last of the factoring. It has x cubed plus 6x squared plus x plus 6. Because there are 4 terms here, we probably all are thinking grouping. So I have this group and this group. In the first group, the common factor is x squared. And if I factor it out, I'm left with an x plus 6. And there appears to be nothing to factor out of the second group. If there is nothing to factor out, we had this once in a while, what could be sitting in front of that group? A 1. Okay, so now I have a common binomial. I will factor it out. I like to write it in front, x plus 6. What's the leftover factor? X squared plus a 1. So grouping was the last technique. I'll use a lot of factoring throughout the rest of the test, but those are the only questions where that was the direction. All right, question number 10. Switching up, it actually goes to the next chapter, and it gives you a rational expression, 2y minus 5 over y squared minus 64, and it wants to know for what real numbers is this undefined. When is a fraction undefined? When the denominator is equal to 0. So I will take y squared minus 64, set it equal to 0. I have a quadratic equation to solve, and the only technique that you would have known at the time this was happening was factoring. It's also perhaps the easiest. That's the difference of squares. If I now use the zero factor property, I get that y is -8 or y is +8. The answer to my question, for what values is this undefined? It is undefined for these two numbers. It didn't say describe the domain. It said for what numbers is it undefined? It is undefined for these two. Is that okay? All right. And by the way, that was the first question out of Chapter 7, if you wanted to make some notation of where things come from. Number 11, it asks you to simplify. And it gives the rational expression 3x plus 2 over 12x squared plus 23x plus 10. All right, if I'm going to simplify, which is code for reduce, the numerator doesn't change, 3x plus 2. The denominator, I think, is factorable. What do you think one of the factors just might possibly be? 3x plus 2? That's the only way this is going to reduce. So I think it might be, but I know I need a plus and a plus. To get 12x squared, I have a lot of choices. 1 times 12, 2 times 6, 3 times 4. I'm going to try 3x times 4x. To get 10, it could be 1 times 10 or 2 times 5. I'm going to try 2 times 5. Now, why did I just happen to choose those? Because I was thinking maybe that would show up again. I do need to check it. The outer product is 15x. The inner product is 8x. Those do add up to be 23x. So I have the right factors. Now, do you see the common factor of 3x plus 2? Your final answer, simplified, is 1 over 4x plus 5. Not a guarantee that'll always work, but when it's an academic textbook type problem, it might work. Problem number 12. You're asked to multiply or divide. Problem number 12 is x. Let me give myself a little more room. I have x squared plus 8x all over 6 times 49 over 7x plus 56. Can I factor this numerator? Yes, common factor of x, and it's x times x plus 8. I don't need that anymore. This denominator, what do you see down here? 7. 7's the common factor, and it's 7 times x plus 8, so I don't need that anymore. Do you see common factors? X plus 8, x plus 8. What else do you see? 7 goes in there once, 7 goes in there 7 times. I don't see anything else. I think I'm left with 7x over 6. Whoops. Okay. Number 13 is a division problem. It starts as 4x plus 20 over 6 divided by 3x plus 15 over 15. So I'm going to, if it's okay with y'all, I'm going to do 2 steps at once. When I do keep for the first fraction, not only am I going to keep it, but how about we factor that numerator? Can I call that 4 times x plus 5 over 6. I have kept it, but I have factored what I could. Change to multiplication. Flip the second fraction. So the 15 goes on top. On the bottom, I'm going to go ahead and factor 3 parentheses x plus 5. Okay, what do you see that I can divide out? The x plus 5s. All right, 3 goes into itself once, 3 goes into 15 5 times, in 4 and 6, 2 goes in there 2 times, 2 goes in there 3 times. I don't see anything else. I have a 2 times a 5 over a 3. So I have 10 over 3. So keep, change, flip, and I did my factoring at the same time. Okay, number 14, ask us to add or subtract. And I have 6x over x plus 1 plus 7 over x minus 1 minus 12 over x squared minus 1. Not an equation. We haven't had an equation here. All right. Do y'all all agree that this last denominator is really x plus 1 times x minus 1? And I don't need that anymore. What is the least common denominator? Because it's addition and subtraction. Okay, I need x plus 1 times x minus 1, x plus 1 times x minus 1, x plus 1 times x minus 1. Now I compare the original denominator to the new one. When I compare, what's the new factor? X minus 1. So I'll multiply the top by that, and I'll get 6x times x minus 1. Next one, what's the new factor? X plus 1. So I'll multiply 7 times x plus 1. And in the last one, there's no change, so there's no change. Okay. One denominator of x plus 1 times x minus 1. The first numerator, if I distribute, that gives me 6x squared minus 6x. Plus sign. 7 times x is 7x. 7 times 1 is 7, and minus a 12. So I use distributive property for the first numerator and for the second numerator to get these terms. Collecting like terms, I have 6x squared, a minus 6x and a plus 7x is plus x, a plus 7 and a minus 12 is minus 5, all over x plus 1 times x minus 1. There is a chance that that numerator factors. All right, I know I need 1 plus and 1 minus. To get a 6, I can either use 2 and 3 or 1 and 6. I'm going with 6 and 1. And I'm going to try a 5 and a 1. And I think I've got the right value but the wrong sign. I've got the signs wrong right now. My outer product is negative 6x. My inner product is positive 5x, which would give me negative 1x, but I want positive. So now does that work out okay? 6 minus 5 is 1. So this is reducible. Common factor of x plus 1 divides out, and that gives me 6x minus 5 over x minus 1. And I hope somebody's checking to make sure that I'm getting the right answers every time. All right, number 15. This time, it's the first time I've seen the instruction solve. So I have an equation that's about to come up. And I'm going to leave a little space. I have 1 over x plus 7 plus 5 over x plus 6 is equal to negative 1 over x squared plus 13x plus 42. This is an equation, which means not only do I find the least common denominator, but I'm going to multiply by it. This denominator factors into x plus 6 times x plus 7, which is kind of nice. All right, what's my LCD? X plus 6 times x plus 7. I'm going to multiply it times the first, the second, and the third terms. So, x plus 6 times x plus 7, x plus 6 times x plus 7, x plus 6 times x plus 7. Okay. In the first group, what divides out? The x plus 7s, and I am left with x plus 1 times 1, x plus 6 times 1, which is x plus 6. In the next group, the x plus 6's divide out, and I'm left with 5 times x plus 7. And you might have gone ahead and distributed that. I'm just waiting. But I had this 5 times x plus 7. Equal sign, everything divides out over here, and you're left with a negative 1 on the right. All right, I keep my x plus 6 plus 5 times x is 5x. 5 times 7 is 35. That's equal to negative 1. I do not have a quadratic equation. This is linear. Add my x's for 6x. Add 6 and 35 for 41, and that equals negative 1. I'm going to get the constant to the right-hand side, subtract 41. That means 6x is negative 42. Divide. X is negative 7. But do you remember this is one of two kinds of problems that you have to check to see if you accidentally, unintentionally invited an answer in that doesn't check. X is negative 7. Is that going to cause me any trouble as far as the domain of the original problem? Yes. If x is negative 7, this denominator becomes 0. So does this one. But if it even happens for one of them, it's trouble. So that's not the answer. What is the answer? There's not an answer. It's no solution. Okay, one more from chapter 7, which is 16. It is a complex fraction. And it asks you to simplify x minus 9 over 8 all over x plus 1 over x. I don't know how well you recall this lesson. There were two types of problems. There was the type that had single fraction over single fraction, and I called it type 1. Then there was the kind that had sums and differences of fractions. That was type 2. Well, this is type 1. This was, to me, the easier kind. This is the one you write as the division problem. This is x minus 9 over 8 divided by x plus 1 over x. Keep, change, flip. X minus 9 over 8 times x over x plus 1. Is there anything I can reduce, simplify, divide out? No. you may leave your answer as x times x minus 9 over 8 times x plus 1. Although if you multiplied it out, that would be fine too. Times all the terms. Yes, sir. I will tell you that most probably whatever is represented on this review will be represented on the final because I use a test generator and I don't change up problem types. Okay, so the first 9 problems were from Chapter 6, and these have been from Chapter 7, and now we're about to go to that little group of questions that we had from 3, 8, and 9, which had to do a good bit with graphing. And I've got myself some graphing grids when I need them. All right, 17 through 22, it asks you to write the equation. Whoops, again. When I write the equation of a line, I'm either going to have y equals mx plus b as an answer, or I'm going to have y equals a number or x equals a number. Those are the only 3 forms I'm going to come up with. So let's look at 17. It says the slope is -4 and the line goes through -6, 2. Is everybody in agreement that this is not an x equals or a y equals? Because those happen when the slope is either 0 or undefined. Okay, so I have the slope and I have a point. Point slope will be one of the most used tools. Y minus y1 is equal to m times x minus x1. Remember that the point given is always x1, y1. So it is y minus 2 is equal to -4 times x minus -6. Minus minus, plus plus. So I have y minus 2 is equal to, using the distributive property, -4x is a -4 times a positive 6, -24. Add 2 to both sides, and I will get y is equal to -4x minus 22. And that's the equation of my line. It's in that nice slope-intercept form. You'll want to make sure that you've got your blue sheet so that you've got these forms as you need them. Number 18. I have that the slope is 5/4 and it goes through 0, 4. Well, this is not a horizontal or a vertical line. This is one of the slanted ones. Anybody have a little ding, ding, ding going off in their brain? Something special? You've got a 0 in the x position, which tells you that this number is b. Remember that if this is 0, then the number here is b. Now, if you don't remember that, you'll need to treat this as the point x1, y1 and do point slope, and it'll work out fine. But y equals mx plus b, y equals 5/4 x plus 4. Done. If you recognize that if the x-coordinate is 0, then the y-coordinate is the y-intercept. And like I said, if not, you could do it as point slope. You'll get the same answer. Do I need to do it as point slope? Okay. All right, 19. We have a line that goes through 221 and 977. Well, what is it I need to know about this line first? Slope. So m is equal to y1 minus y2 over x1 minus x2. The y's are on top, the x's are on bottom. So I'm going to have 21 minus 77 over 2 minus 9, which gives me, I'll wrap around, the numerator will be negative 56, and the denominator is negative 7, which simplifies to the number 8. That's the slope. Am I through with the problem? No. Now use m equals negative 8 and a point. Okay, pick the positive point, or it's, what do you want me to pick?
No, the 8 is positive.
Oh, duh. Thank you. Big blobby 8. That's ugly. What point would you like me to pick?
2 and 21.
Sure. I usually go for the smaller numbers when it doesn't make much difference. All right, so I have a point, I have a slope. Point slope, y minus y1 equal to m times x minus x1. Y minus 21 is equal to 8 parentheses x minus 2. So y minus 21 is equal to 8x minus 16. Add 21. And y is equal to 8x plus 5. Okay, two-part problem. Number 20, it says that it is a horizontal line and it goes through the point 3, 2. What do you know about the equation I should write down for a horizontal line? It is y equals a number. Look at your point. What does y have to equal? Because your point is xy, it has to be y is 2. Number 21. It is a line that goes through 1, 8, and it is parallel to y equals 5x minus 7.
That's 21.
Oh,
The vertical line.
22. It is a vertical line. So sorry. You know what? I think I can redeem myself. No, I can't. Come on. Right. I do need to go away. Okay. That's 22. 21. Vertical line through 0, negative 1/3. What's the form of a vertical line? It is x equals something. From your point, what is the x value? 0. And good thing it was that kind of problem, because I could sneak that one in. Okay, now back to 22. I have a line going through 1, 8, parallel to y equals 5x minus 7. Okay, parallel. Supposed to trigger something in your mind. If lines are parallel, what's true? Okay. The m is 5 for this line, so the m is 5 for this line because the word parallel means or tells you It's the same slope. So now, I have an equation that goes through 1/8 with a slope of 5, point slope. Y minus y1 is equal to m times x minus x1. That's y minus 8 is equal to 5 times x minus 1. Y minus 8 is equal to distributive property, 5x minus 5. Add 8. Y is equal to 5x plus 8. It is parallel, but it goes through the given point. It is just a very good thing I'm not taking a final exam today. A little word to the wise. Don't get just 4 hours sleep the night before you take a final, because you probably just won't do your best. I'm not doing a great job today. Sorry about that. Okay. Are we okay with that much? Function notation was something else that came in that 3, 8, 9 little group that we did. Your calculator might be helpful on these problems. On number 23, we have h of x is equal to x squared plus 2x plus 1. And you are asked to find h of negative 2. Make sure you put it in parentheses, even if you're using a calculator. That's negative 2 squared plus 2 times negative 2 plus 1. What does that give us? 4 minus 4 plus a 1, which is 1. H of negative 2 is 1. And that's all you'd have to reply with. We talked a lot about what would the ordered pair be and so on, but all I'm looking for is the number. 24. You're given f of x is 8x to the third, and you're asked to find f of 4. So that is 8 times 4 to the third power. Make sure that you do what the order of operations says, which is exponents first. 4 to the third power is 64. And 8 times 64 is a big number. 512. And that's your answer. And I think the last one of those, I have f of x is x minus 6 over 7x. And I want to know what f of negative 4 is. So that's going to be negative 4 minus 6 over 7 times negative 4. By the way, what would be the only number that would cause me trouble if I plugged it in? What could I not plug in here? 0, because 7 times 0 would be 0, and I'd be in trouble. All right, that gives me a numerator of negative 24. No, I can do this. Negative 10, and a denominator of negative 28. Can we reduce that? Okay, 5 over 14. It was negative over negative, so we're making it positive. Dividing 2 into each of those, I get 5 over 14. Okay, and that takes care of the first page of the review. Okay, the next questions are graphing questions, so I have included graphing grids for myself. Number 26. Asked me to graph f of x is equal to 2x plus 4. Now, even though that's in function notation, it is really y equals mx plus b. So based on that, where will I begin? 4 on the y-axis. And then how will I move? Well, the slope is 2. So it's 2 over 1, which is up to right 1. So begin at 4, up to right 1. Up to right 1. Up to, you can do that once or you can do it a bunch of times. Have some kind of straight edge. And there's your line. Okay, anybody have a question about that one? All right, the next one is number 27, and it is f of x is equal to negative 4. Well, that really is the same as y is negative 4. What kind of line is y equals negative 4? It is horizontal. It's going to cut through the y-axis at negative 4. And that's all there is to that one. All right. Number 28, a little bit different, might not expect it. It says graph the line that goes through 0, 3 with a slope of 1/2. Well, you're given a starting point and you're given the slope. And the slope is up 1, right 2. So begin at the point 0, 3. And from there, go up 1, right 2. And you could repeat that as often or not repeat it and get your line. I sort of missed my points, but close. Okay? And by the way, the starting point, if it just says it goes through a point, it does not have to be the y-intercept. It could be any point on the grid. And then if I give you the slope, you use those as your moving instructions. Now, when I give you an equation, it is the b value, and it's always on the y-axis, but not necessarily in every problem where I just give you a point. Is that okay? All right, I'm going to go back to my, maybe, where did it go? There they are. Nope. Okay, well. Let's look at number 29. These next few problems have to do with the shifting. The shifting up, the shifting down, the shifting right and left. Number 29, and I'm not using a grid because this is just going to be a tiny little graph, although I do have grids provided on your answer sheet for your final. Okay, this is based on the x squared graph, so does everybody agree it's going to be a little u, but how is it going to shift? Okay, what does the plus 4 on the outside tell you to do? Go up 4. So this graph should look like 1, 2, 3, 4, and the vertex will be there, and it looks like that. So identify what shape it's going to be. This is for yourself. This is all I'm going to have to see on the test. But for yourself, what shape it's going to be, how is it going to shift? Number 30. I have g of x is the absolute value of x plus 5. Okay, what shape is an absolute value graph? A V. When I add 5 inside the function, inside the absolute value, it's going to go horizontal, it's going to go opposite direction of what the sign says, so it's going to go left 5. So it should look like that. (31) says f of x is equal to x cubed plus 5. Although you didn't have homework questions on x cubed, you did have exam questions on x cubed. What's the shape of the x cubed? It's the squiggle. It's the squiggle. So it looks a little bit like that. The plus 5 is added on the outside, so which way will it shift? Up 5. If it's in parentheses before the cubing, then it would go to the left. So it should look kind of like that. It should shift up 5 units. Now the last one has 2 transformations on it. It says, what if f of x is absolute value x minus 4 plus a 1? Okay, what's the shape of an absolute value function? A V. And what does the inside minus 4 tell you to do? Go right 4. The outside plus 1 tells you to go up 1. So I'm thinking in my mind about this V, but I need it to go right 4 and up 1, so it's going to be over here. You'll have to draw it. You will literally have to do, it's an open-ended test, it's not multiple choice, so it'll be just like this.
The squiggle doesn't matter where.
Oh, the squiggly? Well, no, as long as that point is right there, everything else would be okay. That does matter. That point that's normally at 0, 0, that's the one I'm looking for. Where did it go? That's why this point is the point that I had to see go right 4 and up 1. Okay? Going to number, we skipped the 33 to 36 on this version of the review, and we are going to go to number 37, and it's a graph. And I am asked to graph x plus y is less than or equal to -2. It's an inequality. I still want the y by itself on the left-hand side. So I'm going to subtract x from both sides, and I have y is less than or equal to -x minus 2. This line, will it be solid or dotted? It'll be solid. Will I shade above or below this line? It says less. Y gets smaller as it goes down, so it's below. Where will I begin? -2. The slope is -1. Put it over 1. That's down 1, right 1. Okay. Begin at -2. From there, go down 1, right 1. I can do that as many times as I want. I have a solid line. I'm supposed to shade below it. And I would get a picture that looks something like that. Okay, ready to go on? Number 38. I need to graph x is greater than negative 3. Okay, there's no y in this problem. What does the line x equals negative 3 look like? It's a vertical line. So is this going to be a vertical solid line or dotted line? Dotted. Because it's going to be vertical, I can't shade above and below it. I have to shade either to the right or to the left. It says greater than. Where does x get bigger? To the right. So I'm going to shade to the right. So I'm going to locate negative 3 on the x-axis. I'm going to draw a dotted vertical line through that. Sort of. Oh, that's a mess. And I'm supposed to shade to the right. Okay. Green. Every point over here has an x coordinate greater than negative 3. All right. Number 39. I'm supposed to graph y is less than or equal to negative 3. Well, what does the line y equals negative 3 look like? It's a horizontal line. Will this one be solid or dotted? It'll be solid. And because it says y is less than this, I will shade below. And so I need horizontal line cutting through the y-axis at negative 3, solid. And you told me to shade below it. And there we go. The last two questions, and there won't be this many on the test, but you're just getting more practice, or I hope you think you're getting more practice. Numbers 40 and 41 are systems of inequalities. So I've got 2 to graph for each one of these. The first one has, this is number 40, it has y is less than 2x plus 8, and it has y is greater than or equal to x minus 7. For the first one, looking at the inequality symbol, I know that it's going to be dotted. I'm going to shade below. I'm going to begin at 8, and my slope is up to right 1. I'm going to go ahead and write this information on the second one. It's solid. We're going to shade above. I'm going to begin at negative 7, and I'm going to move according to the slope, which is 1 over 1. Okay. Let's do the first one in blue. Okay, begin at 8, up to right 1. 1, 2, 3, 4, 5, 6, 7, 8. There's 8. There's up to right 1. I could go down to back 1, because you can always reverse both directions. Dotted line. And shade below. Okay, that's the first one. The second one, solid above. Okay, begin at negative 7. 1, 2, 3, 4, 6. From there, go up 1. Wait a minute. Up 1, right 1. Shade above. Now, this is going to not going to see a great picture here. I'm going to shade above this second one. Do you see that the overlap is this region between them? And you don't, in my vision, you don't even see that where they intersect down here. Is that what it looks like on the answer key as well? You just get this. You can tell that they would eventually intersect down here, but you just don't see it in this view. And the points in here satisfy both of the inequalities. Okay, 41. I have x plus, nope. I have y is less than or equal to 3x minus 2, and I have x plus y is greater than or equal to 2. First one's already in the slope-intercept form. I know that we're going to have a solid line. We're going to shade below. We're going to begin at -2, and the slope is up 3, right 1. The second line's not quite right. I need to subtract x from both sides so that I have y is greater than or equal to -x plus 2. This is again solid. It is above. I'll begin at 2. My slope is -1, so I'll go down 1, right 1. Okay, first one. Begin at -2. Go up 3, right 1. And it was solid. It was shade below. Second line. Solid above, start at 2. Go down 1, right 1. Shade below, no, shade above. That one was below, that one's above. Whatever you want, whatever you want. If you just took your regular old pencil and shaded one direction, the other direction, you could see where the overlap was and kind of darken it in, that'd be fine with me. You can even draw me a little arrow and say, it's this piece, whatever, as long as I can tell. Or you can bring highlighters or matte pencils or whatever you want. Has everybody had a lot of fun with graphing and we're ready to move on? All right. We are to, I believe, chapter 10. And these are going to be radicals for a little bit. Problem number 42. It says to simplify the square root of 112 x squared y. Now, to simplify a radical, if it is a perfect square, you're good. You just take the square root, but that's not a perfect square. So I will factor it into a perfect square times a non-perfect square. All righty. Can you think of a perfect square that goes into 112? 16? And it's 16 times what? 16 times 7. 16 is a perfect square, 7 is not. Their product is 112. That's good. X squared. That's a perfect square. It goes in the front radical. Y, not a perfect square, and no way to factor it, so it goes to the back radical. What is the square root of 16x squared? 4x times the square root of 7y. And that's my simplified answer for 42. 43. I'm still supposed to simplify, and I start with 18 k to the 7th q to the 8th. Perfect square, non-perfect square. 18, how will you factor it? 9 times 2. What about k to the 7th? K. Keep k to the 6th and send a single k back here. What about q to the 8th? All of it. It's a perfect square because its exponent is even. Excuse me. Square root of 9 is 3. The square root of k to the 6th is k to the 3rd. The square root of q to the 8th is q to the 4th times the square root of 2k. Yes. To take the square root of a base with an exponent, you cut the exponent in half. All right, 44. It says to add or subtract, and we have 3 times the square root of 8 plus 3 times the square root of 200 minus 6 times the square root of 18. What I'm going to have to do is simplify each one of these, hoping that maybe I get some like radicals. No guarantees. So I'm going to go do each one of them. I have 3 times the square root of 8. Keeping the 3, can you simplify the square root of 8? Blank times blank. 4 times 2. Keep the 3. The square root of 4 is 2, and that's times the square root of 2. And 3 times 2 is 6 times the square root of 2. I'm going to send that up here and put 6 times the square root of 2 underneath that, plus. I have 3 times the square root of 200. Keep the 3. Can you help me factor the square root of 200? I heard it. 100 times 2. That's 3 times the square root of 100 is 10 times the square root of 2, or 30 times the square root of 2. Send that back up. 30. Last one, I'll put the minus sign up there. I have 6 times the square root of 18. Keeping the 6, square root of 9 times the square root of 2. So that's 6 times 3 times the square root of 2, or 18 times the square root of 2. So I have 6 plus 30, 36, minus 18 is 18 times the square root of 2. Yeah. And the problem's kind of rigged. We did some where they didn't all turn out to be the same. This one did. So if they turn out to have the same radical, then you can add and subtract their coefficients. Okay, going to 45. It is multiplication of radicals. And we have the square root of 2 plus the square root of 6 times the square root of 2 minus the square root of 6. Do you happen to remember what you call, oops, I just made this thing mad. When you have a sum and a difference of radicals, what are these two called? Conjugates. And so something nice happens when you multiply conjugates. The product of the first, what is the square root of 2 times the square root of 2? It is 2. rational 2. The outer product and the inner product will cancel. And what is square root of 6 times the negative square root of 6? It is negative 6. Positive times negative gave me the negative. And then what is 2 minus 6? Negative 4. We got a nice rational answer. That's always going to happen when you're multiplying conjugates. All right. Then we have a couple to rationalize the denominator. Number 46 is 2a over the square root of 5. What do I multiply top and bottom by to get rid of that radical in the denominator? Square root of 5 over the square root of 5. All right, multiplying the tops, well, that's rational, that's irrational. All I can do is sit them close to each other. 2a times the square root of 5 over, what's the square root of 5 times the square root of 5? It is rational 5. It is the square root of 25, but that turns into 5. There's nothing I can simplify. There's nothing I can reduce. I'm done. 47. I'm still rationalizing, but the denominator is different. I have 3 over 7 minus the square root of 3. What am I going to multiply by? 7 plus the square root of 3. The conjugate, 7 plus the square root of 3. Now the numerator, distributive property, so 3 times 7 is 21. 3 times the square root of 3 is 3 times the square root of 3. The denominator, conjugates, product of the first. 7 times 7 is 49. Those weren't radicals. Outers and inners, they don't count because they will cancel out. What is the negative times the positive square root of 3? Minus 3. This is going to give me 21 plus 3 times the square root of 3 all over 46. I can reduce this if and only if these three numbers have a common factor. And I don't think they do. So, I'm done. So we've added, subtracted, multiplied, and divided with radicals. And now we have some radical equations. Number 48. We're getting close to the end? Hope. All right. I have the square root of 5q plus 6 is equal to 6. What do I do in an effort to get rid of the square root in an equation? Square both sides. I'm going to square the left side and I'm going to square the right side. When you square a square root, what happens? Radicand pops out. I get 5q plus 6 is equal to, when you square the 6, you get 36. This is a linear equation. It's not quadratic. Subtract 6. That gives me 5q is equal to 30. Divide by 5. And q is 6. Do you remember that you have to check these? You have to check the rational equations and you need to check the radical equations. So I have the square root of 5q plus 6 is equal to 6. That's the square root of 5 times 6 plus 6 has to equal, whoops, sorry, went crazy on me. Okay. Doesn't want me to check. Oops. All right, I think I already said what was supposed to be going on there. Simplify on the left-hand side. We can probably do this in our heads. 5 times 6 is 30, plus 6 is the square root of 36, is 6, and that's a true statement. Stop it whenever you can tell that it's either true or false. That means that this is a nice, valid answer. Check it in your head if you want to. All right, 49 may be a little bit longer. It is the square root of p squared minus 3p plus 54 is equal to p plus 3. Square root, so I'm going to square both sides. Now the left side's pretty easy to square because it's a radical. That's going to give me p squared minus 3p plus 54 equals. Now on the right side, you need to be careful. When you square p plus 3, many people would need to think of it as p plus 3 times p plus 3 so that you won't lose anything. You're going to get p squared plus, the outer product is 3p, but the inner product is 3p for 6p plus 9. Right now, this looks like it's quadratic. But when you attempt to get all the p squareds on one side, you realize that they cancel out. So you get negative 3p plus 54 is equal to 6p plus 9. It's not quadratic because there was a p squared on both sides. They canceled out. I've got to get my p's together on one side. What do y'all want me to do? Do you want me to add 3p or do you want me to subtract 6p? Pardon? Add 3p. Add 3p. That's going to give me 54 is equal to 9p plus 9. Subtract 9. That's going to give me 45 is equal to 9p. Divide by 9. And 5 is equal to p. I do need to check it. I have the square root of p squared minus 3p plus 54 is equal to p plus 3. It's the square root of 5 squared minus 3 times 5 plus 54 is supposed to equal 5 plus 3. Square root of. This is going to be 25 minus 8 plus 54. That's 17. Help me out here. I'm without any kind of calculator, so my brain's way too tired to add. How much? Okay. Which is kind of what I wanted because the right-hand side is equal to 8 and the square root of 64 is 8. So this one checked. Okay. Now wait a minute. Oh, okay. The answer's right. Her answer's right. It's that I multiplied 3 times 5 and got 8. She didn't. Okay. It is 64, but not by the numbers I had written down. So it depends on which of my mistakes you were following. Alrighty. Number 50. I have 4 minus 5i plus 2 plus 2i. All right, I'm adding and I might be subtracting complex numbers. When you do it, when it's an addition problem, you pretty much ignore the parentheses. Add the real parts for 6. Add the imaginary parts for minus 3i, and you're done. So add the reals, add the imaginaries. It's just combining like terms. Number 51 has 4 plus 5i minus -6 plus I. Well, what do you have to do when you've got a subtraction? Change it to addition, change the next, everything inside the parentheses to its opposite. Now, the real parts, +4 and +6 for 10. The imaginary parts, +5, -1 for 4I. Is that okay? Number 52. It is a product of complex numbers, and it says to write the answer in the form A plus BI. So I have 6 minus 8I times 2 plus 9I. Use FOIL. Product of the first is 12. Outer product, 54I. Inner product, -16I. Product of the last, minus 72I squared. But do you remember what I squared is equal to? -1. So I can get rid of the I squared, but it always changes the sign of the term it belonged to. So I have 12 plus 72, which gives me 84. And then for the imaginaries, I have 54 minus 16, which is how much? 38I. All right, one more complex number problem. 53. I have 9 minus 4I over 5 plus 8I. What am I going to do? What am I going to multiply by? 5 minus 8I, the conjugate of the denominator. All right. I'm going to use FOIL on top. The product of the first, 9 times 5 is 45. Outer product is -72I. Inner product, -20I. Product of the last, plus 32I squared. And I will come back and simplify and clean that up in just a minute. I much prefer to be working with the denominator where I'm multiplying conjugates. Product of the first, 25. Outers and inners don't count. Product of the last, minus 64I squared. All right, now it's time to clean things up. I squared on the top makes that a -32. That blob is negative. On the bottom, that I squared makes that a positive. So I think I'm going to change this to minus. Okay. What do I have? I have 45, this is the top, 45 minus 32, 23. I have 72I that's negative and 20I that's negative for -92I. All over 25 plus 64, 89. Oh, I really would be okay with this answer. If this were a math lab question, it would want 23 over 89 minus 92 over 89. And pause because I messed up and hit a button. There is absolutely no telling. Okay, just start that over. 45 minus 32 in most universes would be 13. I was in an alternate universe for just a moment. Minus 92i all over, and did I have this number right? 89, and maybe I'll just quit while I'm ahead on that one. You could break it into its two components if you wanted to. The next problems come from our chapter 11 that we didn't have a formal test in this class. Number 54 asked me to solve, but it gives me a technique. It asked me to do it by factoring. So I have 4x squared minus 5x minus 9 equals 0. So this problem came from chapter 6, actually 6.6. Is there a common factor? No. So I'll go with my trial and error. I'm afraid my instincts have failed me now. I do know there's 1 plus and 1 minus. I'm going to ask y'all for some help. For the 4x squared, do you want me to use 1 times 4 or 2 times 2? 1 times 4. So 1x times 4x. For the 9, do you want me to use 1 times 9 or 3 times 3? 9 and 1. And because I got some good help, I think we are in good shape. The outer product is negative 9x. The inner product is 4x, which is exactly negative 5x. So y'all made me look like I was doing it right. This is equal to 0. So I can use the 0 factor property. Either x plus 1 is 0 or 4x minus 9 is 0. That means x is negative 1. On the second equation, I'd have to add 9. 4x is 9. Divide by 4. X is 9/4. Quadratic equation solved by factoring. Number 55 falls under the same directions. Solve x squared minus 16 is equal to 15x. This is quadratic. Is it ready to be factored? No, because it's not equal to 0. So I'll have to subtract 15x, and I'm going to nestle it in between these two terms. So I have x squared minus 15x minus 16 equals 0. No common factor. I'm going to have 1 plus and 1 minus. I need an x and an x. Factors of 16 with a difference of 15. 1 and 16. Right? So that tells me that my answers are x is negative 1, x is positive 16. You don't have to check for extraneous solutions on these. All right, so we've done 2 by factoring. The next 2, it says to do by completing the square. And I have z squared plus 10z plus 3 is equal to 0. And you couldn't do this one by factoring. It's not factorable. Is it in the right form for completing the square? No. Completing the square, the leading coefficient has to be a 1. That's good. But the constant needs to go to the other side. So I have z squared plus 10z, I'm going to put plus a blank, is equal to, when the 3 goes over, it'll be negative 3 plus the same blank. Okay, I grab the coefficient of the z term, which is a 10. I take half of it. Half of 10 is 5. I square that for 25. Take half, then square. Add 25 to both sides. On the left-hand side, I have a perfect square trinomial, and how does it factor? Z plus 5, quantity squared, and on the right-hand side, I get 22. Use the square root property now. That'll give me z plus 5 is equal to plus or minus the square roots of 22. I cannot simplify the square root of 22, So I subtract 5 from both sides, putting it in front. Z is equal to -5 plus or minus the square roots of 22. And just leave it like that. You don't need to separate it for me. Are we okay? Ready to go to the next one? 57. Still completing the square. I have x squared minus 10x plus 34. So it has a few similarities. Equals 0. It's not ready for completing the square. I need to move the 34 to the other side. So I'm going to have x squared minus 10x plus a blank equals -34 plus a blank. Same steps I did in the previous problem. This time I'm taking -10. Half of it is -5. Square the -5, and you still get 25. The difference in this problem is on the left-hand side, you're going to have x minus 5 quantity squared, whereas in the other one we had z plus 5. Equal sign, -9. Square root property, x minus 5 is equal to plus or minus the square roots of -9. Can you simplify the square root of -9? That's plus or minus 3i. That's what x minus 5 is equal to. Add the 5 to both sides. X is equal to 5 plus or minus 3i. Just leave it combined. Okay, last two problems. Quadratic formula. I'm supposed to use the quadratic formula to solve 2x squared plus 10x equals -3. Is that in the right form for me to start the quadratic formula? Nope, it needs to be equal to 0. So that's going to be 2x squared plus 10x plus 3 is equal to 0. Whether you do this mentally or you write it down, you need to recognize that A is 2, B is 10, and C is 3. X is equal to the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to -b means the opposite of the b value, which is going to be -10 plus or minus the square root of 10 squared minus 4 times 2 times 3 all over 2 times 2. So x is equal to -10 plus or minus the square root of 100 minus 24 all over 4, which gives me x is equal to -10 plus or minus the square root of 76 over 4. And question, can you simplify the square root of 76? Can you think of a perfect square that goes into 76?
19.
Pardon?
19.
19 and 4. So it is the square root of 4 times the square root of 19, which is 2 times the square root of 19. X is equal to -10 plus or minus 2 times the square root of 19 over 4. So I went off and simplified. Last question on this. Can you reduce this fraction? Yes. All of the rational numbers have a common factor of 2. 2 goes in there minus 5. 2 goes in there once. 2 goes in there 2 times. X is equal to negative 5 plus or minus a 1 that wouldn't be written times the square root of 19 over 2. Oh, goodness. There's your answer. Okay, last problem. See if I can make it through. 59. I have 6m squared plus 8m plus 1 is equal to 0. It's in the right form for the quadratic formula. A is 6, B is 8, C is 1. M is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So m is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 6 times 1 over 4. So m is equal to negative 8 plus or minus the square root of 64 minus 24. I just wonder where I got a 4. I mean, that one doesn't even make any sense. 2 times, yeah, okay. 12. I thought I was going to actually make it through this one unflawed, but no such luck. I would do better if y'all would just say what the next step is and I'll write it down. Negative 8 plus or minus the square root of 40 over 12. All right, I have a couple of things to consider. Can I simplify? After I do, can I reduce? Square root of 40. 4 and 10. So that's 2 times the square root of 10 for a simplified version. So m is equal to negative 8 plus or minus 2 times the square root of 10 over 12. Can we reduce? Yes. 2 is a common factor. 2 goes into negative 8, negative 4 times. It goes into itself once. It goes into 12 6 times. Our answer is m is equal to negative 4 plus or minus the square root of 10 all over 6. Done. Okay, I'm going to go ahead and stop this recording before I say something else that's wrong.